Okay, so the validation set is useful, but it has a weakness. Its result depends on which examples enter the validation set. So suppose we have 20 days, let's say we have 20 days of ice cream sales data. Okay, let's say we use 15 days for training. We don't keep any of the given data for testing, but we simply use 5 days for validation. Okay, we don't keep anything for testing. So 15 days for training and 5 days for validation. Imagine that all of these 5 days are rainy weekdays, or all of these 5 days are extremely high temperature days, basically heat wave days. So the model's validation score will look bad, not because the model is terrible, but because the validation set was an exceptional or unusual set, because all of them are exceptional rainy days, flooding days, or high heat wave days. Okay, on the counter side, let's assume that these 5 days are, let's say, the festival days, as we had seen in our earlier example. Let's say these are all festival days, okay, because of which more people have come to that place and there are more sales. Okay, so again the validation set may tell that, here it will tell us that the model is too bad, but it is not actually, and here it will say that it is too good, but it is not actually. Okay, so the main problem is, because we are having one single validation set, one single split, one single validation set, therefore it can be misleading. Okay, because all the days or all the types of the days may not be included in that validation set. Okay, secondly, the percentage, right? So should we say that 90% should be used for training, or 75% should be used for training, or 82% should be used for training, let's say? How will you decide? So this is second problem. How will you decide this? How to decide which split is better? Okay, one particular split may be lucky, one particular split may be unlucky. Okay, then another thing is, the data that which we have held out for validation set, we may lose some patterns, we may lose some patterns in the validation data. So instead of getting trained on, let's say, amount of rainfall and sales, or whatever, let's say amount of rainfall and sales, because we held randomly, we held all the rainy days out for validation, we would never be able to learn the pattern or the relationship between the amount of rainfall and the sales. Okay, so we may lose some important patterns in the validation data. So these are some of the problems, because of which, okay, we say that one single validation data set or validation set is a bad idea. We must have multiple validation sets, but how? So this is where the concept of cross validation comes in. This is cross validation. Okay, so firstly, we want every example or every row should get a chance to be used for training the model as well as for the validation. Every row gets a chance to be used. Okay, I think that's the only thing, instead of having, like, that's the only important point. Every row gets a chance to be used for training as well as for validation. Okay, so what we do is we rotate the validation role. Every row will play this role of validation, but we rotate that role. So for example, let's say we have 12 examples. D1, D2 up to, let's say, D12. Okay, so in iteration 1 or in epoch 1, or basically what we do is we divide them into something called as a fold. So this is the first fold. Now first fold consists of D1, D2, D3, D4. Second fold, it's a standard terminology to call it as a fold. You can also call it as a subset or a partition, but the standard terminology is fold. So second fold consists of D5, D6, D7, D8. Third fold or third partition, third set consists of D9, D10, D11 and D12. Okay, now what we do is, in the first epoch or the first iteration, okay, let's say instead of using epoch, I will use a simpler word, that is first iteration. I will use fold 1 for validation. I will fold by fold 1 for validation, and I will use fold 2 and 3 for training. For training, and the second fold I will use for validation, and so this is rotating validation. You can call this as example gets a chance to be a validation data, basically. So that is the concept of cross validation. Okay.